the benefit, and then it is easily solvable. So determinant method, if you use, then you cannot find the relation. You can just prove that it is independent or dependent. But if you use the combination method formula, then you can find the relation. Okay, now let us. Yes.
Ma'am, yesterday what you taught in the class, I was actually absent.
You don't have your group. I think you should be connected with each other.
No, ma'am, I'm connected. Just I want a brief overview from your end, ma'am.
Linearly independent and dependent vectors.
Okay.
And those vectors are the elements of the matrix. Okay. And book I have uploaded. It is given very well in the book. Those books you can. The language is also very simple. You can understand.
Thank you.
Okay. So all of you all be connected among yourself. If anyone is absent, you can discuss what has been taught earlier. Okay. And now let us move to other topic. Solution of system of equations. Linear equation. We have a syllabus linear equation. Solution of solutions we can make. Linear equation. So linear equation, you know the meaning.
Screen is not shared.
Yes, I'm sharing it. I forgot. So solution of system of linear equation. So linear equation, you know the meaning. Meaning of linear equation, that means they will be connected by a single degree term. Okay. So if you have a system of equation like a1x plus b1y c1z is equal to d1. Again a2x is equal to d3. So you have this form of system of equation. So you can convert this into a matrix form. You can write it as A1 so you will have X downward direction in column form.
Ma'am, you are muted.
It gets muted. Okay. So this part you can write it as A, and this you can write it as X, this part, entire part, and this you can write it as B. So finally you get up the system as AX is equal to B, where X are the component X, Y, Z, A is the matrix, and this is again another matrix. So now how do you find the system of the solution of this equation? You have studied in 11 and 12, I think, in matrix you have studied that if you have this system of equation, you used to apply which rule? Do you remember?
Kramer's rule.
Yes, CR rule or Kramer's rule. You used to apply the Kramer's rule. In that Kramer's rule, there was a word, consistency and inconsistent system of equation. Isn't it?
Yes, ma'am.
So we will not be applying this rule because this has already been studied. So you will be using the row reduction formula to find the solution of the system of equation. Now this B can be either equal to 0 or not equal to 0. If B is equal to 0, then we get a homogeneous system of equation, right? If B is not equal to 0, then we get a non-homogeneous system. So you will have two forms of system of equation which can be either homogeneous or non-homogeneous. Now if you have a non-homogeneous system of equation, non-homogeneous, where B is not equal to 0. So what you can do, you will have either a solution. When it is a non-homogeneous equation, you can either have a solution which is called consistent system of equation. Consistent system. Or you can have no solution, which is called inconsistent system, or non-consistent inconsistent system. Now again, this consistent system, if there is no solution, that is fine. Again, if the system is consistent, you can have again another two situations. Anybody can say what are the other two systems?
Unique or infinite.
Either you will have a unique solution, or you will have infinite solution. Now, how do you understand whether you are having a unique solution or infinite solution? One simple method is that if the determinant of the matrix is not equal to 0, and that is equal to the order of the number of variables or order of the matrix, then you can say that the system of equation is consistent and have a unique solution. But if you use that determinant technique, it will be difficult to find what are the solutions. You can just say that it is having a unique solution. Like if it is not equal to 0, then you can say that you may have some infinite solution. But those values of x, y, and z, it will not be easy to find by using the determinant method. Then that is why you apply Cramer's rule, where you take x by the determinant of some value and so on. So over here, what is the simplest method is that you can apply the row reduction formula. So we construct a matrix which is written in the form of A is to B. Okay. So A is to B means you will have this matrix. This symbol actually is dividing the element of row with the B element. So this matrix is called the augmented matrix. Okay, this is given the name as augmented matrix. So our augmented matrix, you will have the element A1, B1, C1, A2, B2, C2, A3, B3, C3. Again, you will have D1, D2, D3. So this element, this is called the augmented matrix. So the first part of this matrix, you can see that this first part is the matrix A, and the entire matrix is called the augmented matrix. So based on this augmented matrix, we can as well as the nature of this augmented matrix as well as this matrix, we can judge whether the solution is unique or not, or whether it has a solution or not. So different properties. The first one is that if rank of the matrix A is to B, that means rank of augmented matrix is equal to the rank of the matrix A, which is equal to number of unknowns. Unknowns or number of variables, whatever you can say. Hello?
हेलो
हाँ मैडम,
सारे पेज पे करना है
हाँ सारे पेज में करना है ऑफिशियल चीज है ना.
अरे ये पूरा हम आएंगे अभी डिपार्टमेंट
अच्छा.
कि वो आएगा लेटर था
तो हार्ड कॉपी कर भेज देते हैं, आप आए हैं तो अभी रहेंगे ना?
हाँ हम यही कर रहे हैं. तो
कहाँ पे, मतलब कहाँ पे? अपने डिपार्टमेंट
में अपने रूम में.
अच्छा, हम भेज रहे थे अभी. ठीक है ठीक है.
अगर ये देर हो जाता तो हमको बोला हम आ जाएंगे.
अच्छा, अभी हम पता कर लेते हैं, ठीक है, कि ऑफिस में है कि नहीं. ठीक है.
हाँ ठीक है. ओके.
Just 1 minute, I am just coming. Okay, hello. Now I'm back. So we were here, okay? I think I'm audible. Hello.
Yes, ma'am.
So
Yes, ma'am.
I was here. So rank of this augmented matrix and the rank of the matrix is same, and that will be equal to the number of variables. Or you can say number of unknowns. Then we will have a unique solution. So this is matching with the determinant of the matrix itself. Because they are equal, that means this is the same thing. Then system of equations have unique solution. Now another case. If the rank of augmented matrix is equal to rank of the matrix A, but less than the number of variables. Infinite number of solutions. And the third case is if rank of augmented matrix is not equal to rank of the matrix A, is inconsistent, that is have no solution. Clear? So this is for the non-homogeneous system of equation.
Ma'am,
Yes.
ma'am, you said that if rank is less than number of variables.
Yes.
So, ma'am, in that case also rank of AV is less than RS, right?
In that case also, in that case I cannot get it what you are saying. Like see, you imagine you are having over here 1, 2, 3. You are having 4, 5, 3 and 0, 0, 0. Okay, you are having the variable over here x, y, z. And over here you are having some variable, like suppose 1, 2, and this is 0. So what is happening? So when you multiply these terms, so you will obviously see that you are unable to get a proper value of another variable, because to solve the equation, to get all the variables, the number of equations should match with the number of variables. Isn't it?
Yes, ma'am. Ma'am, I am saying that if a number of variables, ma'am, what is RA actually first of all?
R is rank. This I have written the short form rank.
And what is RA is to be?
This is rank of the augmented matrix. See, I mentioned over here. This is the augmented matrix which contains the matrix itself with the right-hand side term of the equation.
With solution.
System of equation.
Yes, ma'am.
And the R is the rank.
Yes, ma'am.
Ma'am, please scroll down.
So these things are there in the book, but I have just written it so that you can note down and it is easy for you to get it.
And please scroll down once.
Once explain the part like why if rank of A is to B is equal to rank of A, then why they have.
What
Can you explain why if rank of A is to B, then also is equal to rank of A, then they have unique.
Yeah, because see over here, this matrix, in order to get the solution, what will happen? This determinant should be equal, not equal to, as you used to study in Cramer's rule also.
Yes, ma'am. Yes.
Determinant should be not equal to 0. So when determinant is not equal to 0, that means you will have the number of equation will be the same as the number of variables.
Yes, ma'am.
So in that case, you will get a unique solution. Like if this becomes less, if this the other row is 0, that means determinant is not equal to 0 means what? You will not have all the elements on a different element, unique element, isn't it? That means the rank should be less. As we have studied, no, if the determinant is not equal to 0, then the rank should be less. If the rank is less, then what you are getting? The number of equations that you are getting is less than the number of variables. Can you get it? Like if the determinant is equal to 0, then one row should be equal to 0 or any element should be 0. So when you construct the system of equation, you will see that the number of unknowns will be less than the number of equation, because every time in order to get a unique solution, the number of unknowns should match with the number of equations so that you can put the value and you can get the solution.
And ma'am, what's the need for checking like rank of A to B is equal to rank of A?
Yeah, this is a technique of finding the solution. Like when you used to study the Cramer's rule also, why you used to do the determinant? X by determinant of those values, again y by determinant of this value. Do you remember? Is
Yes.
equal to 1 by determinant of the matrix. You used to do to get the solution. So this is actually the technique of getting the solution.
Okay, ma'am.
Okay. So this is not there in your syllabus, Cramer's rule, since you have already studied. So you have to use this technique. Now this was the situation for the homogeneous equation, non-homogeneous equation. Now what will be the situation? Looking at this, what you can say for the homogeneous equation? When B is equal to 0. So what you can say?
If A equal to 0, then X have infinite solution.
If A is equal to 0, means if number 1 point, if and over here the augmented matrix, no need of argument because the elements are already 0. Okay, so the main focus will come on the matrix itself. Like over here we constructed an augmented matrix because all the elements were not 0. But over here, since all the elements are 0, whether you write or you don't write the augmented matrix, it doesn't affect anything. So you can just consider the rank of the matrix. So if the rank of the matrix is equal to number of unknowns,
Unique solution.
yeah, and what will be the form of solution?
Unique.
0, 0, 0.
Yes, all the solution will be 0, 0, 0. So in mathematical term, you can write the trivial solution, okay? Trivial solutions are 0 solutions. So I'm writing trivial solution. And if it is less than 0, less than number of variables,
Infinite many solution.
yes.
Infinite.
And what are the nature of solution? Non-trivial. So this will be clear if you do the examples, okay? So this is your theory.
In second case, instead of infinite solution, could we say more than one solution?
Yes, you can say. But this is better. Over here you can say 0 solution, but trivial is better. So you should learn, as you come to the higher standard, you should learn new words, new mathematical terms.
Ma'am, what trivial solution?
Trivial solution means zero solution. All the solutions are zero.
Okay.
Solutions are. Okay, now let us take one example. So I'm deleting this, okay? These are already given in your book also. Now let us take the example.
Ma'am, zero solution means number of all the solution is 0, 0, 0.
Yes.
And for no solution, we use inconsistent.
Yeah. Okay, solve this. So you apply the technique, you construct the augmented matrix A is to B, and then find the rank by applying the transformation. So obviously you have to do the row transformation, because if you do the column transformation, then augmented matrix elements you cannot apply the operation. Okay, so only row transformation is suitable here. I hope everyone knows how to do the row transformation, because this you will be using several places. If anybody have not understood, you can ask.
I mean, second equation there is 37 written there.
Yes.
And there is 37 written there in second equation.
Second equation you are having x plus 2y plus 3z is equal to 4.
And the rank of augmented matrix is coming to.
No, I was thinking that you will make a mistake somewhere here. Okay, final matrix what you are getting, just post it, I will explain. Augmented matrix you have to consider both A and B, not just B. You are looking just B and then you are saying that rank is 2. Isn't it?
Ma'am,
So
x equals to 2, y equals to 1, z equals to 0.
Yes.
Is this the solution?
Yes, yes. Okay, post the solution.
Okay, ma'am.
That part I will explain how you are getting the augmented and rank, augmented value and B value.
उसका माइक का इशू म्यूट कर दीजिए। नहीं बोल रहा है, इसके बाद एक्सटर्नल आवाज दिया है। इधर की बात आ रही है, आपके लिए जो एक्सटर्नल माइक होता है उससे सॉल्व होगा। तो वो माइक का इशू होता है, जैसे मेरा माइक तो आवाज नहीं जाती है, वो उस माइक का दूर से पकड़ लेते हैं। हेडफोन का इशू होता है, हेडफोन में नहीं यूज करता स्पीकर मेरा माइक थोड़ा सा भी अगर मूव कर दूंगा तो आवाज मेरी नहीं जाएगी। तो आवाज का प्रॉब्लम है, एक्सटर्नल बाहर की नॉइज है ना, हो जाएगी। नॉइज तो तभी जा रही है ना जब कोई पकड़ रहा है उसको।
नहीं, उसमें सेटिंग्स में भी है, वहाँ पे माइक्रोफोन के टीम में सेटिंग में देखिएगा। अभी याद नहीं है, लेकिन वहाँ पे देखिएगा ऑप्शन है सेटिंग में, आपका वो एक्सटर्नल नॉइज भी ऐड हो गया, परसेंटेज ऑफ एक्सटर्नल नॉइज वहां पे जाइएगा, आप बता रहे कहाँ, डिवाइस सेटिंग में जाइए, वहां पे आपको दिखेगा। हाँ मीटिंग में ही देखिएगा, वहां पे और सेटिंग्स आता है। हाँ, और उसमें कितना परसेंटेज नॉइज हटाना है, ये करना है।
नॉइज सप्रेशन ऑन कर देना।
हाँ
सेटिंग्स में डिवाइस कॉल डिटेल और वहां पे जाके ये नॉइज सप्रेशन ऑफ करना है।
ये सेटिंग्स में हाँ, वो एक सर का प्रॉब्लम हो रहा है, वो सेटिंग में जाके नॉइज सेपरेशन का ऑप्शन है, उसको बंद कर दीजिए। वैसे वो सर का बैकग्राउंड
नॉइज सप्रेशन को ऑन कर दीजिए।
अच्छा, ऑन करने बता रहा है स्टूडेंट। नॉइज सेपरेशन वहाँ सेटिंग में जाके नॉइज सेपरेशन को ऑन करना है, तो एक्सटर्नल नॉइज। अच्छा, वो सेट कर लेंगे तब। ओके, नाउ लेट अस मूव हियर। So you have got the solution, and somebody post the solution so that I can understand.
मैम पोस्टेड।
हाँ, तो यहाँ पे ट्रांसफॉर्मेशन का रोल बहुत ज्यादा प्ले हो रहा है। यू आर यूजिंग द ट्रांसफॉर्मेशन टू फाइंड द रैंक, यू आर यूजिंग द ट्रांसफॉर्मेशन टू फाइंड द सोल्यूशन, तो वो अच्छे से जानना है। You have not used this technique which I have said.
मैम मेरा है ही नहीं है मैम, ये ऊपर वाला, मैं दूसरी मेरी ऊपर पड़ी है मैम, ये नहीं है, ये बाद
ये
में
कौन भेजा है? अच्छा, ये
किसी और
this
की
is,
है।
see you are doing this process you will face difficulty when I give you another type of problem. इसमें तो हो गया है, अगर जैसे कोई पैरामीटर्स अननोन होगा, अगर कोई पैरामीटर अननोन है, उसका वैल्यू निकालना है, तब वहां पे प्रॉब्लम आएगी। तो इस केस में आ गया, इस केस में ऑल द वैल्यूज आर नोन, सो यू गॉट द आंसर। This process you follow. And see, we are just looking at B part, you don't judge the rank of A or AB, okay? A is to B means including A and including B. इसीलिए कोलोन देके बताया है कि यहाँ पे B भी है, यहाँ पे A भी है। So entire rank को हम लोग लेंगे, not only the rank of B. A rank is this rank. A rank is this rank. Okay. Now let us take another type of problem. इस टाइप का प्रॉब्लम ज्यादातर एग्जाम में आता रहता है। फॉर व्हाट वैल्यू तो हो रहा है, वर्क कर रहा है। And find a solution or more than one solution. So now you have to find for what value of lambda and mu you will have no solution. ये तो ये चीज find out करने के लिए you have to use the theory. Okay. So first you construct.
Don't we, we can even use Cramer's rule even here.
No, Cramer's rule don't use. Otherwise syllabus में ये रहता नहीं. Syllabus में इसलिए so that you learn new technique. ठीक है, जो already पढ़ा हुआ है उसको फिर repeat कोई क्यों करेगा, है ना? If you use the Cramer's rule,
but if it is out of MCQ, then we can use it.
हाँ, MCQ में कर सकते हो, उसमें कोई प्रॉब्लम नहीं है। तो नया इंट्रोड्यूस करके कोई फायदा नहीं है, टाइम वेस्ट करके पढ़ाने का, है ना?
Yes, sir.
Ma'am, there is lambda z.
Only lambda. यहाँ पे
lambda z or only lambda?
This is only lambda. Yeah, lambda z. Z होगा. So you construct A is to B matrix. Apply row transformation. Don't apply column transformations. यहाँ पे स्टूडेंट गड़बड़ कर देते हैं. तो कॉलम ट्रांसफॉर्मेशन करने से क्या होगा? एक एलिमेंट में तो ट्रांसफॉर्मेशन होगा ही नहीं बी के पार्ट में, इस पार्ट में. ठीक है. सो यू हैव टू अप्लाई रो ट्रांसफॉर्मेशन.
अच्छा ओके ना. अच्छा ठीक है, अपने पास ही रखना क्योंकि वो नेक्स्ट वाली चीजें थोड़ा बाद में.
Welcome back to another video, and I'm super excited for this one.
हम नहा ले रहे हैं. ठीक, अभी तो कल देरी है ना, हम खाना नहीं रहे, हम नाश्ता करना.
Ma'am.
Yes.
Ma'am, for no solution, lambda is equal to 3 and mu does not equal to 10.
Yes. Yes, you're right.
For unique solution, lambda not equal to 3.
Yes.
Mu does not equal to 10. For unique solution.
For unique solution, no.
Ma'am, mu can take any value for unique solution.
Mu can take any value, but not equal to 10, because if it becomes 10.
Yes, ma'am.
Or for infinite solution, lambda is equal to 3 and mu is equal to 10.
Yes. Okay. Post your result. Anybody post this solution?
I've shared.
Okay. So this is right. Now, Avia, those who have not understood, I'm explaining them. So after the transformation, you come up to this matrix. Now, Avia, you will see this part is A before the colon sign. So that is entire A matrix. And after including this before colon element and after colon element, that is augmented matrix, A is to B. Now, Avia, if there is infinite number of solution, then the rank of this augmented matrix should be, what will be the condition? Should be equal to the rank of this matrix for the solution, but it should be less than the number of unknowns. That means the rank should be less than 3 because 3 is the variable. So how can you make that? So if you take this lambda minus 3 as equal to 0, if there is 0 value over here, then what will happen? This rank becomes 2. Okay, but if you take 0 over here, then this also rank becomes 2. So will this be possible? Will this be possible? Hello? Did you get the point? See, over here, when this part is 0, when you put the element lambda minus mu, if you replace with 0 value, then this rank is becoming 2. Again, if you put the mu minus 10 value as 0 value, this is also 0, this is also 0, then entire becomes 0.
Yes,
ma'am. So the rank of this becomes 0, A is to B also becomes 0, but the number of variable is 3. Since rank of this is 2, which is less than the number of variables, so you will have infinite number of solution. Now you can see another case. Now if this is not equal to 0, rank of this matrix is not should be equal to 3 to get a unique solution. To make it 3, what you should take this, there should be a non-zero value over here in this part. So lambda minus 3 should be equal to not equal to 0 to make the rank 3, which is equal to the number of variables. Got it? Now A's to B should also be of rank 3. So this in A's to B, this part is already there. This is also not equal to 0. So what you can do, if you take this, the augmented matrix as any value, will that be possible? Because if this is also 0, that will not affect the rank of A's to B, because this A part is already not equal to 0, lambda minus mu. So if you make this as 0 also, it will have no effect. Still the rank of this matrix is 3. So if you make, whether you take equal to 0 or you take not equal to 0, it doesn't affect the rank of this A's to B. So that is why you can take any value to get the solution, to get a unique solution.
Ma'am, we have to see A and A ratio B differently, like both cases.
Yes, you first you have to assume whether the rank of the matrix A, because both rank are included.
And then we have to see for A ratio B.
A ratio B. Not ratio actually, A colon B. Ratio means there may be a mistake.
Yes, of course, ma'am.
Division, colon. Ratio is different, colon. Actually, colon is used just to separate the two elements. It is not the division, okay?
We have to see both differently, both the cases, ma'am, whether it is equal 0 or 9.
Yes, both the cases. Because see, this part A is to B contains A also, no? So if this is not equal to 0, then it is obvious that this rank is rank of this is 3. Then it is obvious because this contains lambda minus mu elements, so you can take any value. Okay, now you have, and when it will have no solution?
Lambda equal to
if this becomes 0, suppose this is not equal to 0, then what will happen? Then the rank becomes 3, which is equal to the number of variables. Then in that case, you will have a solution because system of equation is consistent. But in order to have a no solution, the rank should be less than 3. to make rank less than 3, then you have to take this as 0. So that is why lambda minus 3 is equal to 0. Got the point? But yes, so this is 0, rank becomes this, but the rank of A is to B should also be not equal to rank of this, so this can be not equal to 0 value. I'm just following the theory which I have written. Just following the theory. Now let us come to the example of yes.
Ma'am, can you once explain how do we find the rank of A is to B? Like if rank, like how do you find the rank of B?
Rank of B by transformation. See, if rank of B, if the number of non-zero rows.
And so we'll take the average if the two values are different of A and B.
No, the A is to B contains A also and the right hand side term also. It includes both. A is to B includes both.
And if there's a single matrix,
see, actually what is एक्चुअली क्या है यहाँ पे ना कि अलग अलग मैट्रिक्स ए और बी कंस्ट्रक्ट करने का कोई मतलब नहीं हो रहा. अगर चाहो तो इसको अलग अलग, जैसे अगर समझने के फेर में अगर चाहो तो ए टू बी को अलग कंस्ट्रक्ट करके उसका स्टडी करो और बी को अलग, ए को अलग से बना के मैट्रिक्स उसका स्टडी करो. चीज वही हो रहा है, अलग अलग करके हम लोग स्टडी कर रहे हैं, लेकिन क्योंकि अलग से हम लोग मैट्रिक्स नहीं बना के, क्योंकि ये तो इसी का पार्ट है ना, ये तो एस टू बी का पार्ट है, तो अलग से मैट्रिक्स बनाने का टाइम, मतलब एक ही चीज को 2 बार रिपीट करके लिखने का मतलब नहीं है. इसीलिए थ्योरी क्या कर रहा है, इसी में घुसा दे रहा है, क्योंकि कैलकुलेशन तो एक ही चीज आ रहा है यहाँ पे. लेकिन जब हम लोग स्टडी कर रहे हैं तो उस पोर्शन को लेके स्टडी कर रहे हैं. एस टू बी में जो हमको ए चाहिए उस पोर्शन को लेके स्टडी कर रहे हैं, और एस टू बी में जो हमको कैलकुलेशन चाहिए वो ओवरऑल लेके स्टडी कर रहे हैं. तो इसीलिए सेपरेट, मतलब अगर अज्यूम करो, अगर जिसको समझ में नहीं आ रहा है तो अज्यूम करो कि सेपरेट कैलकुलेशन लेके उसको मैच करा रहे हैं हम लोग. लेकिन सेपरेट कैलकुलेशन करने का कोई मतलब नहीं, क्योंकि ए में भी वही कैलकुलेशन हो रहा है यहाँ पे और एस टू बी में भी वही कैलकुलेशन हो रहा है, क्योंकि ये इसका सब पार्ट आ गया. समझ में आया हम जो बोल रहे हैं? हाँ
yes.
हाँ. Okay, now let us come to the homogeneous system. Solution of this equation. So this is a homogeneous system of equation. तो homogeneous system का थ्योरी पता है?
Ma'am, infinite non-trivial solutions?
Yes. So final matrix, what you are getting?
1, 3, 2, first row elements, second row element 0, -7, -1, and third row element 0, 0, 0.
You reduce it further. If you reduce this further, you will get like this.
मैम रैंक तो वैसे भी मैम कम आ गई है।
हाँ
मैम लास्ट रो 0
अच्छा,
0
यहाँ-
आने पे तो रैंक कम
अच्छा,
हो ही
यहाँ
गई
पे
थी।
हमने एक इक्वेशन को मिस कर दिया है। यहाँ पे 2x1 + 3x2 और एक इक्वेशन है, एक इक्वेशन और है। अच्छा, अब इसको सॉल्व करो। Okay, you do it at home. We will see. Okay, you do this at home. When you solve it, you will finally get this solution. Okay, so from this portion you can understand that you will get x1 minus 11, x2 is equal to 0, and again you will have minus 7 x2 minus x3 is equal to 0. So from these two equations, you can just, your target is to find unknowns, x1, x2, x3. So from this you will get minus 7 x1 is equal to x3. So you can take this any value, say t. So x1 will be equal to minus t by 7 and x3 is equal to t. Now when you put this x1 value over here, you will get x2. So x2 you will get as x1 by 11. So you will have minus.
We'll get the relation between x1, x2, and x3.
Yes. So you will have
That will have
11
infinite
into 7.
solution.
So what does this mean? That for different values of t, you will have different solution. Got the point what I am explaining? So for
Yes,
different
ma'am.
values of t, you will have different solution. That is why it is called an infinite number of solution. So this infinite solution will exist only when the number of equations that you are having is less than the number of unknowns. That means the rank of this matrix is less. Okay, we will meet in the next class. Okay, bye.
Thank you, ma'am.
Thank you, ma'am. Bye.
चलिए